Alright, so we just talked about arithmetic sequences in series when we're adding or subtracting a common difference. So now we're going to talk about geometric sequences in series, which is basically when you're multiplying by or dividing by something. So the definition here is each new term equals the previous term times, again, that keyword, a fixed amount, where we're going to call that fixed amount a common ratio. So common ratio, we're going to think R, right? And for that, let's put a formula down. AN equals your first term, A1, times R raised to the power n minus 1. Alright, so let's think about two sequences here that we have. These are going on forever. We can tell they're never ending because of the dot, dot, dot. So how do I get from each term to the next one? Well, it looks like I multiply by 3's. Again, 3 times 3 times 3, you keep going. So I have a common ratio of 3. I'm multiplying by something. I've got an A1 equal to 1/3. So now I'm going to use my formula. AN equals A1 times R to the n minus 1. Well, AN equals 1/3 times R, which R is actually 3, so let me just put 3 in there, n minus 1. Now, if you can easily simplify this, then you should. And what I mean by that is 3 becomes 3 to the negative 1 times 3 to the n minus 1. And then we have exponents that we can add here. We can take these exponents, add them together, and get 3 to the n minus 2. So if you can do that, then you should, if it's easy to do. If it's not, I'm not going to be overly dramatic about whether or not you're there or not. Alright, so next sequence here, how are we getting from each term to the next? They're getting smaller, so I'm probably multiplying by a fraction. They're also alternating. So notice alternating. If it's alternating, I probably need a negative somewhere. Well, dividing by 2 looks like I'm getting there. So negative 1/2. Negative 1/2 and negative 1/2. So I've got an R value of negative 1/2. Got an A1 of 8. And now I just use my formula. AN equals A1 is 8 times negative 1/2 to the n minus 1. And this is kind of a perfect example of what I would say is not as easy to manipulate. Yes, you can write 8 with 2. You can write this, but that negative complicates things. If you wanted to, you could do 2 to the 3rd, bring out a negative 1 to the n minus 1, and a 2 to the negative n minus 1, and then keep going from there. So if that interests you, you can go ahead and do it, manipulate it. I'm not going to worry about it for now, though. Alright, writing the first 5 terms. By now, we should be pros at this. Yes, your calculator can do it. Again, I'm going to show you, since it's a new series, doing it by hand. A equals, I want A1 first. Negative 2, 1 minus 1. Again, that gives me a 1 because it's 0. A2, negative 2, 1 minus, or 2 minus 1. Again, that's going to be negative 2. A3 equals negative 2 to the 3 minus 1. Well, that's going to give us, well, let's see. If I have R here, well, then I'm going to be getting this by multiplying by negative 2. So multiply by negative 2. Now, yeah, this isn't really tricky to do, but you get 4. And then the rest of the series actually becomes really easy to do without even manipulating it. Negative 2, again, I'm going to put this in parentheses to denote we're multiplying. Negative 8. And finally, A5, we get negative 2, 5 minus 1, gives us positive 16. Then multiply by negative 2. And again, you could just go in your calculator, do a sequence, put in negative 2 to the x minus 1, call x, start with 1, end with 5, and you'll get your 5 terms, which will match up here. Alright, here you go. That one's for you. You're welcome. And we're going to go on to the back and talk about the sums of these. Now, geometric series, you will often see it two different ways. You're going to see the sum of a finite series and the sum of an infinite series. So finite means it has a definite, so again, finite number of terms, or it ends, basically. The formula for this, so you need to memorize this, is sum a1 times 1 minus r to the n divided by 1 minus r. Now, an infinite sum is never ending. So never ending, this is denoted by those good old dot dot dots or the infinity symbol. Again, never ending. This sum is even simpler. You just take the first term, you do 1 minus r. Alright, so let's do 2 examples and be on our merry ways. So first thing to note would be what kind of series this is. Well, how do I get from each term to the next? Looks like I'm alternating, so I know I need a negative. Alternate, and looks like I'm multiplying 2 on the bottom, so I'm probably multiplying by 1/2. Negative 1/2 here. Well, I've got 1, 2, 3, 4, 5, so n equals 5 terms. I've got r equal to negative 1/2, and I know a1 is 1/2. So let's put that in the formula. Sum of 5 terms equals a1, 1/2, times 1 minus the negative 1/2 raised to the 5th power, all divided by 1 minus negative 1/2. I highly recommend in your calculator using 0.5 as the decimal instead of putting 1/2 in. If you were to put that in your calculator, you would end up with 11 over 32 as the sum of the 5 terms. Alright, before we move on to 7 and 8, again, here we know that this is going to be an infinite series. This is where it gets a little bit not so intuitive as to how we're getting to each term. This 3 is a key that you're probably dividing by 3. Well, 3 divided by 3 is 1. But how do I get to 2? Multiply by 2. So let's try 2/3. So 2/3, 2 times 3 is 6, divided by 3 is 2. 2 times 2 is 4, divided by 3 is still 3. So r equals 2/3. a1 equals 3, and that's all we need for our finite sum. So s to infinity, really, equals our first term, 3, divided by 1 minus 2/3. And that is going to actually give you just a solid number of 9. That series will approach the sum 9. Alright, I'm only going to talk about these, and I'm going to let you try them. So key things, already in summation, sum tells me I need a sum. Here's r. This tells me that it's finite. N equals 10. That's how many terms there are total. And 5 is a1. Hopefully you were able to pick those parts out, but in case you weren't. So now you go ahead and you keep going with that one. Here, this infinity tells me it's infinite. That's kind of logical. This is r, of course. and 3 is your A1. So you go ahead again and do that one. So you try and find the sum. So sum here and sum here equals something. Alright, so you do those, go ahead, bring them, and we will talk about them in class.